Hello everyone, welcome to Earth Archives. Please take a moment to like, subscribe, comment and share. Don't forget to hit the notification bell as well. Thank you. Today's historical discussion is the hollow Earth theory that was overturned. What really lies at the core of the Earth? This question has been a long-standing pursuit for scientists. According to a new research report published by CNN on February 21, 2023, scientists now have evidence that the Earth's true core is a solid metal ball about 644 kilometers in diameter, composed mainly of iron and nickel. This discovery could potentially overturn and rewrite existing textbooks on Earth science. If what scientists say is true, the Earth's structure, from the outermost layer inward, consists of the crust, the mantle, the liquid outer core, and the solid inner core. The latest discovery suggests that there is a true core inside the Earth's core. As Dr. Shi Xiangyu, an astronomer at the Taipei Astronomical Museum, explains, this small core was identified through seismology, by studying how seismic waves refract and reflect as they travel through the Earth's interior. This helps researchers estimate the internal structure of the Earth, despite being unable to reach full details about its core. Now, speaking of the Earth's core, we must touch on the once popular theory of a hollow Earth, a theory that, in modern times, might make people laugh, even if they don't understand geology. But if we look back 330 years, even top astronomers believed this theory without question. So today let's dive into this fascinating history. In the past, humans had no clear conclusions about the internal structure of the Earth. Various ideas were based in mythology and belief systems. The first person to make a well-supported guess about the Earth's internal structure was the famous 17th-century English astronomer Edmond Halley. Yes, the same Halley who gave his name to the famous Halley's Comet. He boldly proposed the theory that the Earth is actually hollow. What led him to this conclusion? Halley discovered that the Earth's magnetic field was not as stable as scientists once thought. In the polar regions, compasses were not pointing accurately. To explain this phenomenon, Halley boldly hypothesized that the Earth's center was hollow. In fact, he proposed that the Earth's interior contained a large cavity, within which were three concentric spheres that did not touch each other. These spheres, which he compared to Venus, Mars and Mercury in size, were nested within the Earth like Russian dolls. Halley even used the principle of Saturn's rings to support his theory, suggesting that these floating inner spheres remained suspended due to centrifugal force and gravity, preventing them from colliding. It was these floating spheres that, Halley theorized, caused the variations in the Earth's magnetic field. Many of us have wondered if life exists only on the surface of the Earth. Halley boldly speculated. Life exists on these internal spheres as well, making the Earth's structure similar to a multi-layered building created by God, with different forms of life on each level. This theory, though now largely discredited, was a product of the scientific imagination during the 17th century. An era when the inner workings of our planet were still largely a mystery. Halley's hollow Earth theory intrigued both scientists and the public alike, even though modern geology has disproven it with the advent of seismology and a better understanding of Earth's composition. The hollow Earth theory has since been debunked by subsequent scientific advancements, but it remains a curious chapter in the history of science and continues to spark the imagination of people today in various books, films, and even conspiracy theories. The excitement over discovering Earth's true inner core, however, shows just how much we have learned about our planet and how much more there is still to uncover. That's it for today's discussion. What do you think about the hollow Earth theory? Would you have believed it back in Halley's time? Let me know in the comments below. Don't forget to like, subscribe, and share this video, and hit the bell for notifications on more historical discussions. Thanks for watching. To make the hollow Earth theory more complete, Halley proposed that the spheres inside the Earth contained salt water, held in place by particles similar to glass, preventing the surface oceans from flowing into the inner cavities. He also speculated in 1716 in an idea that would later influence modern hollow Earth theories, that the aurora borealis was the result of luminous vapor being emitted from large holes beneath the polar regions. Thus the magical hollow Earth theory came into existence. Even Halley himself found it somewhat hard to believe and noted in his 1692 records, "This theory, which is so exaggerated and romantic, will likely be immediately condemned by readers until I find enough evidence to support this hypothesis." Halley proposed the hollow Earth theory without sufficient experimental methods, and in a way it can be considered one of the first predictive hypotheses in modern scientific history. However, Halley was not the only one to propose the hollow Earth theory. Around the same time in the German-speaking world, polymath Athanasius Kircher published a book titled Mundus Subterraneus, the Subterranean World, in which he described a great cavity at the center of the Earth. This cavity, he imagined, was like a stalactite cave, containing underground lakes as well as lava and flames. He also suggested that a vortex at the North Pole drew seawater into the Earth's interior, where it was heated and then ejected through the South Pole. Compared to Halley's theory, Kircher's ideas lacked even basic support for his claims. We now know that Halley was deeply mistaken, but at the time, with the limited scientific understanding and technology, it was already known that rotating metal generates a magnetic field. If the Earth's magnetic field was different from expectations, it was reasonable to hypothesize that the Earth's interior wasn't solid rock, but rather might contain rotating bodies made of rock or metal. Because magnetic and gravitational forces had a far more significant influence, it was thought that the internal spheres of the Earth must be in a delicate balance to avoid collapsing. However, there were many unsolved problems with the hollow Earth theory, such as how sunlight could reach the inner Earth to sustain life. Even Halley tried to defend his theory by suggesting that the Earth's inner surfaces might be lined with concave mirrors, which would reflect light from the poles and create a glow as bright as sunlight. However, this idea lacked convincing power. As a result, even during Halley's time, the theory did not attract much attention. Most people responded with, I see, and Halley did not offer further explanations or refinements. By the 18th century, the hollow Earth theory was revisited by two mathematicians, the famous Leonhard Euler and John Leslie. Those familiar with calculus and geometry would certainly recognize the name of Euler, one of the greatest mathematicians in history. He hypothesized that within the hollow Earth there was a warm shell with a diameter of nearly 10,000 kilometers, inhabited by a highly advanced civilization. On the other hand, Leslie believed that beneath the surface were two concentric spheres, with two stars inside that provided light, naming them after the Roman gods Pluto and Proserpina, the gods of the underworld. But it was in the 19th century that the hollow Earth theory gained more widespread attention, thanks in large part to an American named John Cleves Simies. A passionate student of natural history, Simies published his own version of the theory in 1818. His hollow Earth hypothesis argued, "I maintain that the Earth is hollow, containing numerous concentric spheres, and that it is habitable. There are openings at the north and south poles, ranging from 12 to 16 degrees, that allow sunlight to enter. I swear to prove this theory, and I am prepared to embark on an expedition into the interior of the Earth. I hope the world will support me." Sim's passionate belief in the hollow Earth theory and his call for support captured the imagination of many, further cementing the theory's place in the history of scientific ideas, despite the lack of evidence to support it. His idea also helped popularize the notion that there might be uncharted realms beneath the Earth's surface, fueling further speculation and exploration. While today we know that the Earth is not hollow, the hollow Earth theory remains an intriguing part of the history of scientific thought and continues to inspire various adventure stories, fictional works, and conspiracy theories. It highlights how curiosity and imagination have long driven the exploration of our planet's mysteries, even when science had yet to provide concrete answers. As a prolific writer and speaker, John Cleves Simmers tirelessly promoted his hollow Earth hypothesis, even publishing a book titled Simmies, The Journey of Discovery, based on his theory. He went to great lengths to gather funds for an expedition to the polar regions to explore the supposed cavities at the Earth's poles. His version of the hollow Earth theory, with the premise that the poles contain openings that bring light to the Earth's interior, became one of the most well-known variants of the theory. It was one of the many fantasies about the poles before the actual polar explorations took place. Simmers attracted the attention of several key figures, including a wealthy man from Ohio named James McBride. McBride not only wrote articles in support of the theory, but also lobbied Kentucky Congressman Richard M. Johnson to support an expedition to the South Pole. Johnson managed to convince President John Quincy Adams to approve a proposal for an Antarctic expedition, but the plan was ultimately rejected by Congress. It wasn't until President Andrew Jackson took office that a different South Pole expedition plan was reintroduced in 1836. Unfortunately, Sims had passed away in 1829, missing the opportunity to participate in the Antarctic exploration. After Sims' death, the mantle of promoting the hollow Earth theory was taken up by an Ohio newspaper reporter named Jeremiah Reynolds. In 1829, Reynolds joined a hunting expedition to the South Pole to explore the possibility of the polar cavities. However, his efforts were hampered by mutiny, and he was exiled by his companions. He barely survived the ordeal and eventually made it back to the United States. The first formal scientific exploration of the polar regions occurred between 1838 and 1842, led by the United States Exploring Expedition under Charles Wilkes. The mission's primary goals were to create maps, establish new shipping routes, and collect scientific data. The expedition sailed from the U.S. East Coast, rounding South America and heading into the Pacific. During the voyage, they visited Antarctica, but they found no evidence of the massive cavities predicted by Simmers. While the hollow Earth theory was eventually debunked, it continued to be used to explain certain scientific discoveries. For example, in 1846, when mammoth bones were discovered on the Siberian tundra, some suggested that the mammoths may have wandered out of the supposed northern polar cavity, where they were trapped in Siberia. Some even theorized that the mammoths' undigested food, such as seeds in their stomachs, combined with the sudden deaths of these animals, might support the idea of them coming from an inner world. In 1864, the father of modern science fiction, Jules Verne, published Journey to the Center of the Earth, a novel that described a group of explorers venturing into the Earth's interior through a volcano in Iceland. In Verne's fictional world, the inner Earth contained seas and ancient life forms, a vision that captivated the imaginations of readers around the world. In 1869, the American alchemist and hollow Earth proponent Cyrus Reed Teed, in his work, boldly proposed that our world is actually the concave surface of the Earth's interior. According to Teed, the sky above us was the center of the Earth, and on the opposite side of the Earth's crust there existed another civilization. The reason we couldn't detect them, he argued, was due to the dense fog in the inner Earth. He even claimed that the moon was merely another shell within the hollow Earth, an entirely different celestial body. However, it was the Danish scientist Inga Lehmann who truly brought an end to the hollow Earth theory. Through her work on seismic waves and their behavior, she was able to deduce that the Earth's interior consisted of multiple layers, including a liquid outer core and a solid inner core. The movement of these liquid materials generated the Earth's magnetic field and caused changes within the planet's structure. After numerous experiments and validations, it was definitively proven that the Earth's interior was not hollow. Nevertheless, in some respects, Halley was not entirely wrong, because the Earth's structure does indeed consist of many different layers, such as the crust, mantle, outer core, and inner core. Lehmann's groundbreaking discoveries, particularly her identification of the Earth's solid inner core and liquid outer core, were pivotal in rejecting the hollow Earth theory once and for all. Her work set the stage for modern understanding of the Earth's structure and paved the way for further seismic research, which continues to shape our knowledge of the planet's interior today. Of course, looking back now, Halley's hollow Earth theory prompted questions that might never have been asked otherwise, sparking the interest of scientists to investigate the Earth's interior more deeply. As a trailblazer of the Enlightenment era, his hypothesis can be seen as one that ultimately contributed to the progress of later scientific inquiry. The beauty of science lies in its ability to continuously verify, question, and refine ideas. Even incorrect theories can lead to important discoveries, helping to uncover the correct answers. In Halley's case, although his hollow Earth theory was eventually debunked, it played a crucial role in inspiring further exploration of Earth's structure. It pushed future generations of scientists to develop new methods and tools to study the planet's core, eventually leading to the accurate understanding we have today of the Earth's multi-layered composition. So, while Halley's theory was wrong, it had the unintended effect of advancing scientific thinking, a process that ultimately strengthens our understanding of the natural world. Science is an evolving discipline where even mistakes have value, as they can lead to breakthroughs and a deeper grasp of the truth.